In the previous lecture, we discussed there are four types of joins in SQL: left join, right join, inner join, and full join. And there can be three types of relationship that a join can have. First relationship is one-to-one, second is one-to-many, and third is many-to-many. We will see all the examples one by one. So let's jump into the practical. So we have two tables. One is orders, which have two columns, order ID and customer ID. The second table is customer table, which also have two columns. One is customer ID and name. We are saying orders table as A and customer table as B. So let's talk about the primary keys and foreign keys. In the orders table, customer ID is acting as a primary key, and once it is joined to customer table, the customer ID which is there in customer table will act as a foreign key. Now let's talk about the data. So we have four order IDs, 10, 20, 30 and 40, and those belongs to four different customers, 1, 2, 3 and 4. If I talk about customer table, we have four distinct customers, 1, 2, 4 and 5, and these are respective names for them. Now let's take a case of left join. When we apply a join with orders table and customer based on customer IDs, since they are same column in both of the tables, if we apply left join, what will happen? It will fetch all the records from the left table, which is orders table, and will fetch only the matching records from the customer table, which is right table. So let's see the output. First of all, it has simply copied the contents of orders table here, and it has fetched the matching records from the customer table for name. Let's see how. For the first record is customer ID is 1. You can see ID is 1. So it went to customer table and matched that what is the name against customer ID 1. So name is A, that's why it has returned name as A. Similarly, if I talk about customer ID 2 in orders table, it has matched to the customer table and fetched name B. But for customer ID 3 in orders table, it is there, but customer ID 3 is not available in customer table. So it was not able to find the name for that specific customer with customer ID 3. So it has returned null in such case. But for customer ID 4 in orders table, it is available, and it is also available in customer table as well here, and the name is C. So it has returned C. So this is wrong, so I should return C here. So this is right now. So it has returned C name and with respect to customer ID 4. So this is all about left join in one-to-one relation. Let's talk about right join with one-to-one relation. So let's try to understand what is one-to-one. So here we can see that there is no duplicates with respect to customer IDs in orders table, and no duplicates are there for customer ID in customer table as well. So this is known as one-to-one mapping, or you are simply fetching the records without any duplicates. So this is known as one-to-one mapping or one-to-one relationship between two tables. Now let's jump into right join. Right join says fetch everything from the right table, which is customer table, and only the matching records with the left table, which is orders table. So it has fetched customer ID and name here, and then it has fetched the corresponding order IDs from the left table, which is orders table. For order ID, for customer ID 4, for customer ID 5, which is available in customer table, but it is not available in orders table, so it has returned as null. But for all other customer IDs, it was able to find the order IDs respectively. Let's talk about inner join. So inner join says just fetch the common records between both of the tables. The common records between both of the tables, orders and customer, are 1, 2 and 4. 3 is not present in customer table, and the 5 customer ID which is there in customer table is not available in orders table. So the common customer keys are 1, 2 and 4. So it has returned order 4, customer ID 1, 2 and 4 here, and it was able to fetch the names for them from the customer table. Talking about full join for one-to-one relation, it has fetched everything from the left table and from the right table as well. So let's see how. So it has copied all the order ID and customer IDs here and try to fetch the common keys from the right table. So it was able to find out the names for order customer ID 1, 2 and 4, but name was not found for customer ID 3 in the customer table, since it is not there. Similarly, if I talk about right table, it has written 5F here for the customer ID and name, but it was not able to find out 5 customer ID in orders table, so order ID is null. This is one-to-one relation using SQL join, and let's talk about one-to-many. Now, what is one-to-many? One-to-many means you have some duplicates present in one of two tables. So here we can see customer IDs are unique in the orders table, but on the right table, which is customer, we have some duplicates for order ID 1 and 2. Now if I apply left join on these two tables, let's see what will happen. So one thing, just one concept you have to keep in mind. Suppose the customer, let's talk about customer ID 1. So on the left table, orders table, we have, if I'm talking about order ID 1, and what are the count? Count is, let's write it like this, orders and customer. And we are talking about order ID 1. So what is the count of order ID 1 in orders table? It is just 1. And in the customer table, it is 2. So 1 and 2. And then the formula is, let's say the orders table count is M and customer table count is N. So the formula you have to keep in mind is M into N. So this is the formula that you have to keep in mind while working with SQL joins. If you understand this concept, trust me, and I can give you guarantee that you will never face any challenges while working on SQL joins. So if I apply this formula M into N for each respective IDs, we will get how many rows we will get in as the output. Let's see how. So on the left table, orders table, we just have one count of customer ID 1, but on the right table, there are 2 rows for customer ID 1. So this means the total number of records that I will get for customer ID 1 will be 2 if I apply this formula M into N. So I should get 2 records. So let's see how we will get these 2 records. So first of all, if I apply left join, it will take this 10 and will paste it here. But it will also fetch the corresponding name from the customer table, which is A in this case, and will write it here. But it will see that there is one more row which belongs to customer ID 1, since we are applying join on base of customer ID. So it will also copy this name and will paste in another row and will basically create one more row for customer ID 1. So this formula has been proved that it will generate 2 rows for customer ID 1. Similarly, let's talk about customer ID 2. Again, for the left table, the count of customer ID 2 is 1, but in the right table, customer table, the count of customer ID 2 is 2. So let's apply the formula M into N. Again, we are getting 2 rows. So customer ID 2 will also have 2 rows. So it has copied this order ID and customer ID twice and pasted the corresponding name. Against first 2 we are getting B, and against second 2 we are getting K name. So these are the 2 rows for customer ID 2. Then comes 3 customer ID. So the count is 1, and on the right table 3 is not available. So it will just copy this 3 and 30, it will paste it here, and it was not able to find out the name from the corresponding table customer, so it has written null. For customer ID 4, the count is 1, and in right table also count is 1. So 1 into 1, we should get the 1 row for this output. So it has copied 40 and 4 here, and corresponding name is C. I hope this logic is making sense to you. If you just understand this logic, again, I'm reiterating that you will never face any challenges while working on joins. If I talk about right join now, it will first of all see 1A, it is written, and then fetch the corresponding order ID for customer ID 1. Then it comes to 2B, it fetched corresponding order ID for 2. Then comes 4, it was able to fetch, but for 5 is not available on the orders table, that's why it has written order ID as null. Then comes customer ID 1 again, so it has written 1G, and the corresponding order ID is same, which is 10. Similarly 2K, it was able to find one other row for 2K in this table, so it has written that, and the corresponding order ID for 2 is 20. So this is how right join will be applied. Talking about inner join in one-to-many relation, inner join means we have to find out the only common keys between both the tables. But it doesn't mean that this formula will not apply here. The formula will be same in any kind of relations that is there, either one-to-one, one-to-many, or many-to-many. So only common keys are 1, 2, and 4 in between these two tables, as we can see. So again, it will take out the two rows for customer ID 1, two rows for customer ID 2, and just one row for customer ID 4. I hope this is clear to you. Talking about full join, we have to list full table, like everything from left table and everything from right table. But again, this formula will still apply. Two rows for customer ID 1, two rows for customer ID 2, then next row is for customer ID 3, which belongs to orders table, but it is not present in customer table, so it has returned as null. Talking about next ID, which is 4, it has copied 40 and 4 and pasted it here, and it was able to find out name against customer ID 4, which is C. And the last is one more row that is present in right table but not present in left table, so it was not able to find out the order ID and has written null. So this was all about a one-to-many relation. Coming to the many-to-many, which is the actual case that we see in this practical world. So let's focus on these examples. So now, in the case of many-to-many, we have different IDs and the duplicate IDs as well for customer ID in orders table. So one is repeating 2 times, and here in the customer table, one is repeating 3 times. Similarly, in orders table, customer ID 2 is repeating 2 times, and here it is just once. So this is how we can try to now map. Let's talk about customer ID 1. If I want to apply same formula, which is m into n, so the count of customer ID 1 in orders table, which is m, so count is 1, 2, so let's write 2, which is value of m. So let's write m is equal to m is equal to 2, and the value of n is 1 is coming thrice in the customer table, so let's write n is equal to 3. And now let's apply the formula m into n, so we will get 6. So this means in the output we should get 6 rows for customer ID 1. Let's see how it will be performed. So first of all, it will take the first row 10 1 for the customer ID 1 and will paste it here thrice, because in the right table it is coming 3 times, 1a, 1a and 1a. So it will write it 3 times. It will also see that is there any other row for customer ID 1? Yes, it is there in the orders table. So it will copy this and will paste it again 3 times, and will paste and will fetch out the common name in the customer table as well. So this is how it has created 6 rows for customer ID 1. Now let's talk about customer ID 2. So there are 2 rows for customer ID 2 in the orders table, but just one row for customer ID 2 in the customer table. So 2 into 1, which means it will have 2 rows. You can see that 20, 30, so 2 rows are there for customer ID 2, but the respective order IDs are 20 and 30. And names against customer ID 2 is B. So this is done. Rest, we are left with 2 more IDs, 3 and 4. So it has fetched 50 and 60 order ID. It has written it here, but 3 customer ID is not present in the customer table, so it has written as null. And against 4 it has written C, since the customer ID 4 is available and name is C. This was left join. Now talking about right join, the same concept will be applied, which is m into n. So now it will be multiplying 3 into 2. So 3 is in the right table and 2 in the left table. So again we are getting the same answer, 6. So it will again create the 6 rows for customer ID 1. Next, similarly 2 rows will be there for customer ID 2. Then customer ID 4 will have just 1 row. Since it is common, it was able to fetch out the order ID for customer ID 4. And then 6 and 9 customer IDs are not present in the orders table, so it has written customer ID and name here, and order ID was not fetched, so it has written null. Now talking about inner join, this formula still applies here. So m into n, 6 rows for customer ID 1, 2 rows for customer ID 2, and what is the common key that is left, which is 4. So 3 is not present in customer table, and 6 and 9 are not present in the orders table. So it has written 64 and C. So these are the only common keys that are there between both of the tables. Now the last is full join, where everything should come from customer table as well as orders table. So 6 rows. Okay, so 6 rows for customer ID 1, you can see, and then 2 rows for customer ID 2. Then from the left table we are getting customer ID 3. It is written here, and there is one more row from left table which is 4, but it will also fetch everything from the right table, so it will not leave any row blank. So it will also fetch customer ID 6 and 9, will paste it here. So this is how we can apply multiple relations with all of the SQL type of joins, like left join, right join, inner join, and full join, with these kinds of relation: one to one, one to many, and many to many. Now we will be proceeding towards applying all these examples on Snowflake, and then it should make much sense, because if you are clear with this concept, you will not face any challenges with Snowflake SQL as well.